This is Tech Talks Lecture 116, Testing the Electrolytic Capacitor. Today we are going to be discussing the electrolytic capacitor and how to test one to ensure if it's good in circuit and out of circuit. The basic parts of this capacitor, as you can see in the diagram, consist of two electrodes, two plates, and dielectric material. The electrodes are referenced as the anode for the positive and a cathode for the negative. These electrodes connect to two plates that have a specific dimension to meet the design requirements of the capacitor. The plates are separated by a dielectric whose purpose is to keep the plates from touching and allow diffusion current to pass through the capacitor. The electrolytic capacitor has a dielectric of paper which ranges from 1.7 to 4. The dielectric constant is also referred to as the relative permittivity of the paper. Relative permittivity is a dimensionless measure of a material's ability to store electronic energy in an electric field. The prior diagram was theoretical. Now for some actual physical representation of how the capacitor is made and what it looks like. And as you can see from this diagram, we have a cathode foil, which is the negative end, tissue, which is the paper with a permeability of 1.7 to 4. And then you have the anode foil, which would be the positive end. That is rolled up. The positive and negative tabs are cold welded to the foil. And thus that's rolled up and then placed into a can capacitor. This diagram shows you the finished product of the capacitor. You have your anode, your cathode, your separator, which is your dielectric, and the distance between them is the thickness of the dielectric and how it fits into this can that's labeled with the capacitance of that capacitor. Now for the lab. We will be exploring the analog volt ohm meter Mastech 7040. They do not make this anymore, but you just can find an analog voltmeter somewhere. We'll be testing the capacitor out of circuit, but you can do this testing in circuit as well, but just remember what is surrounding the capacitor. Also remember that the current leads voltage in a capacitor, ICE, and the current is not direct current, but is diffusion current. You will see the effect by the movement of the needle. As the diffusion current travels through the capacitor, charging the plates, the needle will move from a low ohm reading to infinity ohm readings and will quit rising once the plates are polarized. And then I'll be testing the cap. And that's it. That's the end of this lecture, and I hope you enjoyed it. Thank you. Bye.
This is the lab portion of this lecture, and we're going to test the capacitor to see if it'll hold a charge. We need an analog voltmeter to do this because you can see the capacitor charge as the needle goes back to infinity. So we have a capacitor that we're going to charge. This is the one we have the pictures of, 2,200 microfarad. And we insert that into our breadboard just for stability. This technique is good to use with a circuit and you're troubleshooting a circuit board. You don't need to take the components out. And as I touch the electrodes with the leads of the transistor, and I have this set on times 10 on resistance, measuring resistance. So that's what we're doing. As you can see, the capacitor takes a charge. I'm going to short it out. We'll do it again. So you can see the capacitor taking a charge. It's very cool. And that tells us it's good. That's it. This is the meter I have is a Mastech 7040. It was really inexpensive, like $22. They don't make this anymore, but at Home Depot or Lowe's, you can find a good analog meter to use to do this test. Thank you. Hope that was fun. Bye.